Welcome back to the deep dive. Today we're getting into something really fascinating, kind of a hidden story in science history, the Solvay conferences.
Yeah, these weren't your typical academic meetups, were they?
Not at all. You could almost say they were like, well, secret weapons designed to force scientific breakthroughs. That's what we're diving into. And you've probably seen the picture, even if you don't know the name Solvay.
Oh, the 1927 one, the most intelligent picture ever taken.
That's the one, just packed with legends. You've got Marie Curie, Einstein, Niels Bohr, 17 Nobel laureates all in one room. It's incredible.
It really is a snapshot of genius.
Exactly. And that photo, well, it's our way in. But the real story, the thing that made it happen, is the Solvay conference itself. So our mission today is to unpack that surprising history, the unique setup that let these invite-only, really high-stakes meetings basically reshape our understanding of reality.
Right. And it's important for you, the listener, to get that Solvay isn't just some dusty old story.
No,
Hmm.
it's still going.
Oh, yeah, very much so. It's an ongoing thing, a really carefully curated intellectual tradition. These conferences, they started way back in 1911, set up by the International Solvay Institutes. And they focus only on the biggest unsolved problems in physics and chemistry.
Okay, so that's key. Not a victory lap for stuff already figured out.
Definitely not. It's a closed-door kind of thing, intense, all about tackling the unknown head-on.
Intellectual combat, you called it.
Pretty much sums it up. And this whole structure, this idea, it came from one person, really.
Who was that?
A Belgian industrialist named Ernest Solvay. He founded the institutes around 1912, 1913. His big idea was to create this perpetual engine for scientific thought.
An engine, I like that. How does it work now? Is it still the same?
The core idea is the same. It runs on a very specific 3-year cycle now. Physics 1 year, then a gap year, then chemistry the next.
So that keeps it focused. Deliberate pacing.
Exactly. And make sure that when these top minds get together, they have to confront the most critical, unanswered questions right then and there. No distractions.
Okay, let's rewind then. Go back to the very beginning. That first conference must have set the tone for everything that followed.
It really did. We're talking Brussels, late October, early November 1911. October 30th to November 3rd, to be precise.
And the topic.
Officially, it was La théorie du rayonnement et les quanta radiation and the quanta. And this was huge because it forced a showdown, really. A clash between two totally different ways of seeing the world.
Okay, let's break that down for the listener. What was the core disagreement? Why was it such a big deal?
Well, you had classical physics, Newton, Maxwell, that whole tradition, which basically saw energy as flowing smoothly, continuously, like water from a tap.
Right, the established view.
Exactly. But then, back in 1900, Max Planck came along. To explain some weird experimental results like black body radiation, he suggested energy wasn't smooth at all. It came in these tiny, discrete packets. He called them quanta.
Packets of energy. Sounds simple now, but back then.
Back then, it was revolutionary, maybe even heretical to some. Classical physics basically said, nope, impossible, must be some kind of mathematical trick. So the 1911 Solvay Conference was the first big international stage where the old guard and these new radical thinkers had to hash it out face to face.
And just looking at the guest list for that first one, you mentioned Lorentz. Curie, Rutherford was there, Poincaré, Einstein. It seems like Solvay immediately had the clout to pull in the absolute top tier.
That was Solvay's genius, or maybe Lorentz's his chair. They made it the place to be if you were serious about these fundamental questions. The invitation itself carried immense weight.
So that's the secret weapon aspect, isn't it? The exclusivity, the sheer brain power concentrated in one room.
Absolutely. The right people focused on the right problem. And Hendrik Lorentz, who chaired it, was apparently brilliant at managing these. Well, let's face it, probably massive egos and intense debates.
Einstein thought highly of him.
He did. Einstein was actually the second youngest physicist there. Only Frederick Lindemann was younger. And Einstein later wrote that Lorentz chaired with, and I'm quoting here, incomparable tact and unbelievable virtuosity.
High praise. And needed, I imagine.
Definitely needed. Because these weren't just polite academic quibbles. They were arguing about the fundamental rules of the universe. The 1911 conference didn't magically solve everything, of course. There wasn't some grand consensus at the end.
But it worked.
It proved the model worked. It accelerated the whole conversation. It pinpointed exactly where the battle lines were drawn, where the next big push needed to happen.
So 1911 sets this incredible precedent. A structured, intense, international debate speeds up science. But then, just a few years later, boom, World War I.
Right. And that just ripped the heart out of the international collaboration that Solvay depended on.
How did the war, the messy reality of global conflict, derail this unique scientific project?
Well, the trust was gone. The spirit of open exchange across borders, which was Solvay's bedrock, it just evaporated in the trenches. After the war ended, the tensions, the bitterness, especially towards Germany, were still incredibly high.
And this spilled over directly into the conferences.
Directly, it came to a head at the Third Solvay Conference, which was held in April 1921.
And this is where we see that uncomfortable mix of science and politics,
Yeah.
right? The exclusion part.
Exactly. Because of the lingering hostility from the war, most German scientists were explicitly barred from attending. They weren't invited.
Wow. Just shut out completely.
Completely. And this, understandably, caused a major backlash in the scientific community.
And it triggered a pretty significant protest, didn't it, from someone very, very famous?
It did. Albert Einstein. Now remember, he'd been a Swiss citizen since 1901, not German. But he was furious about his German colleagues being excluded.
So what did he do?
He declined his own invitation to the 1921 conference. Flat out refused to go. Instead, he accepted an invitation to travel to the U.S. with Jim Weissman. It was a huge public statement.
That's powerful. It really highlights that tension, doesn't it? We like to think science exists in this pure apolitical bubble, but Solvay shows that's just not true.
Not at all. They're tangled together. For Einstein to turn down what was arguably the most prestigious scientific meeting in the world, well, he was saying the ethical principle of open international science mattered more than even attending Solvay.
A moral stand. Did it change things immediately?
Not immediately, no.
Yeah.
That exclusion actually carried over, even with figures like the King of Belgium apparently pushing for reconciliation and supporting the conferences as, a leading international forum.
The politics were still too strong.
Seems so. The Fourth Solvay Conference in 1924, the topic was the electrical conductivity of metals and related topics. Quite technical. It still didn't include key German physicists, people like Max Planck, Arnold Sommerfeld, Max Born, absolute giants in the field. They weren't there.
So the meetings continued, but they were diminished, less representative of the cutting edge.
You could argue that. The sheer intellectual weight was definitely reduced when you excluded a whole nation's leading scientists, especially Germany at that time, in physics.
But eventually, the science, the sheer importance of the questions they were tackling, it must have started to outweigh the political friction.
It did. Which brings us finally to the big one, the conference that usually comes to mind when people do know Solvay.
1927.
Right. This is where it gets really good. The Fifth Solvay Conference. The anti-German sentiment had eased off by then.
Enough for them to be invited back and attend. This one was October 24th to 29th, 1927, and the subject was simply electrons and photons.
Sounds technical, but the implications were massive. This was about the very nature of reality, wasn't it?
Absolutely. The stakes were immense. The whole point was to finally grapple with, discuss, and essentially try to reach some kind of agreement on the newly formulated quantum theory. This wasn't just reporting results, it was building the consensus. And this is the conference from that photograph, the most intelligent picture.
That's the one. And the lineup was just staggering. We mentioned 17 Nobel winners, future or current, out of 29 attendees total.
And Marie Curie was there again?
She was, remarkably, the only person in that room who had won Nobel Prizes in two different scientific fields, physics and chemistry. She's like this historical anchor in the photo, bridging the old guard and the new wave.
And that new wave, the architects of quantum mechanics itself, they were all present.
Pretty much all the key players who had just constructed this radical new physics in the preceding years. You had Niels Bohr, Max Born, Louis de Broglie, Paul Dirac, Werner Heisenberg, Wolfgang Pauli, Erwin Schrödinger. The list goes on.
So Solvay basically forced them all into one room to consolidate everything?
Exactly. It forced the culmination of years of often separate, sometimes competing, lines of research. And it wasn't just formal presentations, the really famous debates, especially between Einstein and Bohr.
Where Einstein kept trying to find flaws in quantum mechanics?
Right. His famous thought experiments trying to poke holes in the uncertainty principle. A lot of that intense back and forth happened right there, during the sessions, over dinner, in the hallways. The official records even capture some of this intellectual sparring. It was happening in real time.
So, okay, step back. What does this 1927 meeting really mean for us today, for the listener? Why is it considered so pivotal?
Well, it matters because that single week in Brussels essentially cemented the foundations of modern physics. The framework that underlies, pretty much everything in modern technology, transistors, lasers, nuclear energy, you name it.
It's where the standard interpretation took hold.
Largely, yes. It's where the Copenhagen interpretation, the probabilistic view championed by Bohr and Heisenberg, really gained the upper hand, intellectually speaking. Einstein wasn't convinced, famously, but the consensus shifted.
Is there a quote or something that sums up its impact?
Yeah, Werner Heisenberg himself, one of the theory's main architects, said it perfectly. He wrote that through the chance to actually talk and argue face-to-face, this conference has contributed extraordinarily to the clarification of the physical foundations of the quantum theory. And then he added, it forms, so to speak, the outward completion of the quantum theory.
Outward completion. So Solvay was the pressure cooker that forged the physics of the entire 20th century, basically.
That's a great way to put it. It didn't invent quantum mechanics, but it ratified it. It made it the official paradigm.
It's easy to get caught up in the physics drama, the quantum revolution. But you mentioned earlier Solvay wasn't just about physics.
That's right, and it's a really important point. Ernest Solvay's vision was broader. He saw this intensive focus model working for other hard sciences too.
So chemistry had its own Solvay track.
It did. The chemistry conferences started in 1922, running in parallel on that cycle we mentioned, and they tackled equally huge fundamental problems in their field using the same kind of high-stakes, invite-only approach.
Can you give an example? What sort of things did the chemistry conferences focus on?
Sure. Take 1937, for instance. The topic was vitamins and hormones. Now, that might sound almost mundane today, but back then, that was the absolute cutting edge where chemistry met biology.
Ah, the beginning of molecular biology, kind of.
Exactly. Figuring out the actual chemical structures and functions of these vital biological molecules. It brought together chemists focused on pure structure with those looking at how these things worked in living systems. It was foundational.
And more recently?
Well, fast forward to 2022. The conference tackled chemistry challenges of the 21st century. So things like green chemistry, sustainable materials, energy storage, the big chemical questions facing us right now.
So the model adapts, and I heard they've even added another field recently, branching out further.
They have, which shows the institutes are still looking ahead. The newest field is biology. They clearly recognize that understanding complex biological systems is one of the next great frontiers.
When did that start?
The very first Solvay conference on biology was just held, April 2024, and the title was The Organization and Dynamics of Biological Computation.
Biological computation. So brains, networks, how life processes information.
Exactly that kind of stuff. They're basically betting that the same intensive, focused, deep dive approach that worked for cracking quantum mechanics and complex chemistry will also work for understanding the fundamental principles of life and intelligence. Whether it's quantum fields or neural networks, the idea is that this pressure cooker environment forces progress.
It's amazing we've kept this laser focus, this incredibly high standard, going for well over a century now, consistently getting the top people in the room.
It really is a testament to the original vision.
But for us, looking back, to really appreciate these breakthroughs, we need the records, right? We need to know what was actually argued, how they got there.
And that's another crucial piece of the Solvay legacy, preservation. The archives are incredibly detailed and historically vital. They cover the period from the very first planning meetings in 1910 all the way up to 1962.
Where are they kept?
They're held jointly at the Free University of Brussels and also at ESPCI Paris. It's a huge collection.
And these aren't just dry proceedings, are they?
No, far from it. They include minutes, detailed notes on the discussions, the objections raised, the arguments back and forth, even those famous Einstein thought experiments we talked about. It's a record of the process of science, the debates and disagreements, not just the final polished results.
And that significance, the value of these records, it's been formally recognized, hasn't it?
Yes, very recently, in 2023, UNESCO officially added the Solvay Conference archives to its Memory of the World International Register.
Memory of the world. So ranking them alongside things like the Gutenberg Bible or the Biotapestry.
In terms of documentary heritage significance, yes.
Yeah.
It's recognizing them as globally important records of human intellectual achievement.
That's incredible. Okay, so let's quickly recap the ground we've covered. We started with that initial foundational clash over quanta back in 1911.
Setting the stage.
Then we saw how real-world politics, the nationalism after World War I, nearly derailed the whole thing, leading to exclusions.
The Einstein protest moment.
Exactly. Then the spectacular comeback in 1927, the Electrons and Photons Conference, which basically solidified modern physics.
The outward completion moment.
And finally, we touched on the ongoing legacy, how the Solvay model extends beyond physics into chemistry and now even biology, and how the meticulous records preserve this unique history. It all circles back to Ernest Solvay's original, quite brilliant idea for this curated invitation-only forum.
And that focus on the process, the recorded arguments, the intellectual struggle documented in those UNESCO archives, that's the final thought I really wanted to leave you with. We love the stories of the lone genius, right? The eureka moment in a bathtub or under an apple tree.
It makes for a good narrative.
It does. But Solvay shows us something else, something perhaps more realistic about how a lot of fundamental science actually progresses. It relies on this structured, intense, recorded, high-stakes conversation between brilliant rivals, forced to hammer out their differences over an unsolved problem.
So the collective is just as important, maybe more so than the individual.
In many cases, yes. And it makes you wonder, looking at the massive challenges we face today, things like climate change modeling, or maybe the ethics and safety of advanced AI, or even complex genetic engineering, which huge unsolved problem now deserves its own modern-day Solvay conference.
Meaning an exclusive, high-stakes, deep-dive forum.
Exactly, complete with those meticulously recorded arguments, designed specifically to accelerate consensus or at least clarify the disagreements. Maybe the next world-changing breakthrough isn't waiting for a lone genius. Maybe it's just waiting for the right conversation to be convened, the right table to be set, just like Ernest Solvay figured out over a century ago.
A fascinating thought to end on. Where should the next most intelligent picture ever taken be focused? Something for all of us to think about. When we try to picture a global health emergency, I feel like our minds almost automatically default to, the movies.
Right, the whole Hollywood version of a pandemic.
Yeah, exactly. We imagine hazmat suits everywhere, sirens blaring through abandoned streets, people instantly collapsing in the supermarket. It's loud, right? It's highly cinematic.
It is. It relies entirely on that visual spectacle to scare you.
But the reality, especially with the news that just dropped on May 15th, 2026, is a lot quieter, and frankly, I think it's a lot more terrifying.
Yeah.
On that day, the Democratic Republic of the Congo declared its 17th Ebola epidemic, this time in the Ituri province.
And, the escalation of that was incredibly rapid. Just 2 days later, the World Health Organization actually escalated the situation. They declared this epidemic a public health emergency of international concern.
Which is a huge deal.
It is. We were suddenly looking at 246 suspected cases, 80 deaths, and the virus was actively crossing the border into Uganda.
Yeah, it's exactly the kind of news alert that just makes your stomach drop. It immediately triggers panic across social media.
Oh, absolutely.
But for this deep dive, our goal is to kind of strip away that sensationalism of the news cycle and definitely ignore the wild exaggerations of those pandemic movies.
Right, we want to stick to the facts.
Exactly. We are relying entirely on a massive, really comprehensive Wikipedia repository of medical, historical, and epidemiological data on the Ebola virus.
And it is incredibly thorough.
It is. So the mission for you listening right now is to understand exactly how this microscopic killer actually operates, where it comes from, the deeply human history of its discovery, and the incredible medical breakthroughs that are finally giving humanity a fighting chance. Okay, let's unpack this.
Well, to ground our investigation, I think it helps to clearly define what we are actually dealing with here. Ebola, or formerly known as Ebola virus disease, is a zoonotic viral hemorrhagic fever.
And just to clarify, zoonotic is just the scientific term, meaning it originates in animals and jumps to humans, right?
Exactly. It jumps the species barrier. Historically, outbreaks of this disease have carried an average mortality rate of about 50%.
Wow. 50%.
Yeah. And in certain environments, that number has actually climbed as high as 90%.
That is just staggering.
It really is. But to defeat a pathogen with that kind of kill rate, we first have to understand the mechanics of why it is so incredibly lethal.
Right. And I want you, the listener, to picture this as almost like a forensic investigation.
I like that analogy.
Yeah, because to truly understand the global terror this disease causes, we have to zoom way, way in and look at the crime scene inside a single human body.
And when you look at the biology of the virus at that level, Its simplicity is almost insulting.
Insulting is a good word for it.
We are talking about a single-stranded RNA virus.
Mm.
Under an electron microscope, it doesn't look like some menacing alien sphere covered in spikes, you know.
Right, like the classic COVID illustrations we're all used to seeing.
Exactly. It doesn't look like that. It actually looks like a microscopic piece of thread. It's a filamentous particle. Usually it's shaped like a shepherd's crook or a U or sometimes a 6.
Just a little squiggly line.
It's a little line. It's only about 80 nanometers wide.
But the part that absolutely blows my mind, its entire genome contains only 7 genes.
7. That's it.
I mean, for a sense of scale, a single human cell has over 20,000 genes.
Right. It's a massive difference.
It's like, imagine a hacker bringing down an entire global banking system with just 7 lines of code.
That is exactly the level of biological sabotage Ebola is executing.
It's wild. Now, before we look at how those 7 genes actually run their code, let's clear up the clinical reality.
Good idea.
Because of pop culture, I think people assume catching this means you instantly start bleeding from your eyes and your pores in the middle of the street. What does the infection actually look like on the ground?
Well, the clinical reality is far more insidious, mostly because of how it starts. There is an incubation period that can last anywhere from 2 to 21 days.
So you could be infected for 3 weeks and not even know it.
Exactly. You're walking around feeling completely fine. Then, when the symptoms finally do hit, they perfectly mimic a sudden severe flu.
Like just normal flu stuff.
Yeah, you get extreme fatigue, a high fever, muscle pain, and a sore throat. It's only days later that the severe nausea, uncontrollable vomiting, and diarrhea really set in.
Okay, but what about the bleeding? Because the Hollywood trope is all about the blood.
Right. The heavy external bleeding is actually surprisingly uncommon.
Wait, really? Because the scientific classification is literally hemorrhagic fever. Like, that implies massive bleeding.
I know, it does. And there's bleeding, but bleeding from mucous membranes or injection sites only happens in about 40 to 50% of cases.
So half the people don't bleed externally at all.
Exactly. When heavy bleeding does occur, it is usually internal. It specifically pools in the gastrointestinal tract.
How?
Yeah. The virus drastically decreases your blood's ability to clot, and it damages the cells lining your blood vessels. But here's the crucial distinction. The blood loss itself isn't usually what kills the patient.
Really? What is it then?
The real killer is hypovolemic shock.
Which is caused by the vomiting and diarrhea, right?
Precisely. The extreme gastrointestinal symptoms lead to massive, incredibly rapid fluid loss.
Right.
So the patient's overall blood volume plummets, and when that happens, their blood pressure just drops off a cliff.
Because there's not enough fluid to keep the pressure up.
Exactly. And without enough pressure to pump oxygenated blood throughout the body, your major organs simply fail from the shock.
And how fast does this happen?
This usually happens between 6 and 16 days after the first symptoms appear.
Yeah.
Yeah.
Which brings us right back to those 7 genes. How is a virus with such a tiny genetic payload managing to do so much catastrophic damage before the human immune system can even mount a proper defense?
Well, what's fascinating here is the sheer devastating elegance of its immune evasion. The virus produces 2 specific structural proteins known as VP24 and VP35.
Okay. VP24 and VP35.
You can think of them as a highly trained strike team taking out a bank's security cameras before the main heist begins.
Okay, I like that. Walk me through the heist.
So when a normal human cell detects a viral intruder, it panics. It sends out a chemical distress signal using proteins called interferons.
It's essentially a cellular alarm system, like one cell gets breached so it screams to the neighboring cells to lock their doors.
That's the exact mechanism, yeah. Those interferons bind to neighboring cells, which triggers a specific signaling protein. It's called STAT1.
Yeah, STAT1.
Right. And STAT1 rushes into the cell's nucleus to turn on the production of antiviral defenses. But Ebola's VP24 protein physically blocks that STAT1 signaling protein from entering the nucleus.
So it barricades the door.
Literally. The neighboring cells never get the message to lockdown.
Wow, so the alarm is completely silenced at the receiver's end.
And at the source, actually. Meanwhile, that second protein, the VP35 protein, directly inhibits the originally infected cell from even producing the interferon distress signal in the first place.
It cuts the alarm wires completely.
Completely. Without the innate immune system slowing it down, the virus replicates uncontrollably. And it doesn't just attack any cell. It specifically targets your immune system's first responders.
The very things meant to fight it.
Yeah. the specialized white blood cells that normally patrol your body, looking to consume pathogens.
So it hijacks the exact cells designed to protect us, turns them into like virus printing factories, and then causes them to self-destruct.
Exactly. And that cell death unleashes a massive storm of inflammation throughout the entire body.
So knowing how efficiently this virus dismantles human biology definitely explains the high death toll. But, I mean, if it's so perfectly adapted to destroying human cells, it begs the question, where is it practicing when it's not inside us? Like, how does it make the jump?
Finding the natural reservoir of this virus actually required decades of intense ecological detective work.
I can imagine.
Yeah, between 1976 and 1998, field researchers tested over 30,000 mammals, birds, reptiles, and insects from outbreak regions across Africa.
30,000?
Yeah, they were desperately looking for the virus's hiding spot.
And the prime suspect they eventually landed on was the fruit bat. Right.
Specifically, researchers identified 3 types of fruit bat that can carry the virus in their systems without ever getting sick.
So their immune systems just somehow tolerate the pathogen perfectly?
Which makes them the ideal biological vessel. I mean, they fly vast distances every single night, dropping partially eaten fruit, saliva, or guano into the deep forest.
And here's where it gets really interesting, because the jump from those bats to humans isn't just a matter of random bad luck. It is deeply tied to how human beings are actually altering the environment.
Yes, that is a crucial point.
Outbreaks are consistently triggered by deforestation and climate change. When severe droughts hit Central Africa, it creates intense food insecurity, and logging destroys the deep forest canopies.
So you end up pushing these infected bat populations out of their natural habitats.
Exactly. They get pushed closer to human settlements just looking for food.
And it initiates this deadly domino effect. A stressed bat drops a piece of infectious fruit. Then a chimpanzee or gorilla or maybe a forest antelope eats that fruit and becomes infected.
Right. And because food crops have failed due to the drought, human hunters in these local rural communities are forced to rely heavily on hunting these wild animals just for protein.
Bushmeat.
Yeah. The hunter comes into contact with the infected blood while butchering the meat, and boom, the virus successfully finds a new host.
And once it establishes that beachhead in the human population, the global fear immediately shifts to how it spreads.
Yeah, and I know exactly what you're thinking right now listening to this. You're probably picturing it spreading through the air on a crowded subway, like a common cold. We need to definitively debunk that right now.
It is the most critical distinction we can make today.
Yeah.
There have been 0 documented cases, either in nature or in human outbreaks, of this virus spreading to the air from human to human.
0.
None. Human transmission requires direct physical contact with the blood, vomit, feces, or other bodily fluids of a person who is actively showing symptoms.
Right. It has to enter your body through broken skin or mucous membranes, like your eyes, nose, or mouth.
Exactly.
You aren't going to get infected just by breathing the air in the same room as someone, unless, they are so severely ill that they are violently coughing or sneezing large, wet, infectious droplets directly onto your face.
Which requires very close proximity.
Exactly. But as with any forensic investigation, our source material throws us one bizarre curveball that completely complicates the whole theory.
Ah, yes. This raises an important question, and it stems from a highly unusual laboratory incident involving pigs.
Pigs?
Yes. Researchers discovered that pigs infected with a specific strain of the virus, the resistant strain, actually could transmit it through the air to primates in a laboratory setting.
Without any direct physical contact whatsoever.
Exactly.
Wait, so it's a completely airborne transmission, but only if it's coming from pigs?
Yes.
If it's airborne in pigs, that means the virus must behave differently in their anatomy than in ours, right? Does it attack their respiratory system instead of their blood?
Spot on. It comes down to where the virus physically accumulates in the host. In humans and other primates, the virus replicates aggressively throughout the body and specifically concentrates in the blood and the GI tract.
Okay.
But in pigs, the virus accumulates in massive, localized concentrations directly inside their lungs.
Oh, wow.
Yeah, so when an infected pig exhales, sneezes, or coughs, it is expelling huge, dense clouds of the virus into the air. Primate lungs simply don't harbor the virus the same way.
Terrifying, sure, but also a massive relief that our human lungs don't turn into virus cannons.
A huge relief.
But because human transmission requires such intimate contact with fluids, it means the history of these epidemics is deeply tied to human behavior.
Yeah.
Specifically, the danger zones are caregiving and mourning.
Right. That intimate, tragic connection is visible from the very first recorded outbreaks. We can trace the formal discovery of the virus back to 1976.
To two simultaneous outbreaks in Central Africa, right?
Yes, one was in Sudan, and the other was in a small rural village called Yambuku that was in what was then Zaire, now the DRC.
The story of the Yambuku outbreak is incredibly heartbreaking.
It really is.
So in August of 1976, a village school headmaster named Mabalo Lokela returned from a trip near the Ebola River. He fell ill with a very high fever, and at first the local clinic just assumed he had a severe case of malaria.
Which is incredibly common in that region.
Right.
And because the initial symptoms mimic malaria so perfectly, they treated him with quinine.
But obviously his symptoms just kept worsening. Severe pain, vomiting blood, extreme exhaustion. He died 14 days after his symptoms started.
A tragic loss.
But the true tragedy is how his treatment inadvertently started the fire.
This is where the fragility of local healthcare infrastructure becomes the virus's greatest weapon. Lokela was treated at the Yambuku Mission Hospital, which was operated by Belgian nuns.
Okay.
At the time, they were routinely giving vitamin injections to pregnant women at the clinic. But they were operating with severe supply shortages. They were reusing just 5 glass syringes for the entire hospital.
Oh, no.
And crucially, they were not properly sterilizing the needles between patients.
They were essentially creating a biological superhighway, just injecting the virus directly into the bloodstream of dozens of unsuspecting patients.
Yes. The outbreak exploded, ultimately killing 280 of the 318 people infected in Zaire.
That is an 88% fatality rate? That is terrifying.
It is. The local doctors were instrumental in getting blood samples shipped to Belgium, though. That's where a researcher named Peter Piet and his team finally isolated the new unknown virus under a microscope.
And they named it after the nearby Ebola River to avoid stigmatizing the village of Yambuku.
Right. And for years after that discovery, the narrative of the disease remained mostly confined to these devastating but highly localized outbreaks in remote African villages.
Until 1989,
Right.
when the story took a wild turn that brought the virus right to the suburbs of the United States.
The Reston incident.
Honestly, this reads exactly like a thriller novel. A research facility in Reston, Virginia, which is just a few miles from Washington, D.C., received a routine shipment of macaque monkeys from the Philippines.
And suddenly the monkeys start dying off rapidly from a mysterious hemorrhagic fever.
So the facility sends tissue samples to the U.S. Army Medical Research Institute. An electron microscopist looks at the sample and sees that unmistakable shepherd's crook shape.
They realize they have an active filovirus outbreak sitting in a suburban office park.
Panic naturally ensues. A military team in full biohazard gear has to come in, euthanize the surviving monkeys, and systematically decontaminate the entire building.
But the real shock wasn't the monkeys. It was the human handlers.
Right. Blood samples were taken from the facility workers. 6 of them tested positive for the virus. One handler had even accidentally sliced his finger open with a bloody scalpel while performing an autopsy on an infected monkey.
That should have been a death sentence.
Absolutely. But none of them got sick?
Not a single symptom.
Which had to be the most confusing relief in medical history.
It forced the CDC to realize they were dealing with a completely new strain, which they named the Reston virus.
The pick one from earlier.
Exactly. While it was highly lethal to macaques, it had a very low pathogenicity for humans. It could enter human cells and replicate enough to trigger antibodies, but it simply didn't cause the actual disease.
So it was a massive sigh of relief, yes, but it proved how easily these pathogens could hide in commercial cargo and cross international borders undetected.
Which tragically foreshadowed the darkest chapter in the history of the disease, the 2013 to 2016 West African epidemic.
Yeah. Unlike previous outbreaks that were contained to isolated rural villages, this one managed to reach densely populated urban centers in Guinea, Liberia, and Sierra Leone.
Epidemiologists achieved an incredible feat by tracing that entire massive epidemic back to a single index case. One case. It started with a 1-year-old child in a remote Guinean village who died in December 2013. Likely after playing near a hollow tree infested with fruit bats.
That is heartbreaking.
It is. From that single child, the virus slowly burned through the community, eventually reaching the capital cities and spreading across borders.
The numbers are just staggering. Over 28,000 people were infected and more than 11,300 died. It became the largest outbreak ever documented. But why did it get so out of control there compared to the localized outbreaks of the 70s and 80s?
If we connect this to the bigger picture, the West African epidemic exposed the severe vulnerabilities of the region's health security. You had a highly mobile population moving through densely packed urban slums.
R-
But more importantly, the local health infrastructures were completely overwhelmed and lacked basic resources. We're talking about clinics without sufficient protective equipment, and in some cases, without running water to wash hands.
So the actual places people went to get help became the hubs of infection.
Precisely. The WHO reported that at one point, 10% of the dead were healthcare workers.
Bad percent.
The doctors and nurses caring for the sick were paying the ultimate price. Without the ability to safely isolate patients or safely handle the highly infectious bodies of the deceased during traditional burial rites, the hospitals and funerals essentially functioned as amplifiers for the virus.
It was an absolute wake-up call for the entire world. The horrifying scale of that epidemic forced the global medical community's hand, basically kickstarting unprecedented research and funding.
Yes, it changed everything.
For decades, if you got infected, doctors couldn't offer much more than standard supportive care, basically hooking you up to an IV for hydration and managing your pain while hoping your immune system won the literal war happening inside your veins.
Just waiting it out.
Right, but the post-2016 landscape, it is completely different. We are finally mounting a massive medical counterattack.
The shift in therapeutics has been nothing short of monumental. By 2019, clinical trials in the DRC yielded incredible results using monoclonal antibodies.
Let's break that down because it sounds like heavy medical jargon. Like, how exactly do those work?
Essentially, scientists managed to engineer synthetic immune proteins in a laboratory.
Okay.
So instead of waiting for the patient's compromised immune system to figure out how to fight the virus, they flood the patient's body with these lab-made proteins.
Gotcha.
These synthetic antibodies act like microscopic caps. They physically bind to the outside of the virus, completely blocking it from being able to dock with and enter human cells.
Oh, that's brilliant. It's like changing the locks on the doors before the virus can even turn the key.
Exactly. And in trials, treatments like Inmazeb and Suvimab were found to be highly effective if administered early enough. That alone is a game changer. But perhaps even more significantly, we finally have a highly effective FDA-approved vaccine, the RVSV-ZBOV vaccine.
Yes. And its deployment has totally revolutionized outbreak response, right? During the massive Kivu epidemic in the DRC between 2018 and 2020, health organizations utilized a strategy called ring vaccination.
I did.
How exactly does that work in practice? Because they aren't just vaccinating everyone in the country, right?
Right, that would be impossible.
Yeah.
Think of it like cutting a fire break in a forest to stop a wildfire.
Yeah.
You don't try to put out the entire fire. You remove the fuel directly around it.
Oh, I see.
When a patient is confirmed positive, teams frantically track down every single person that patient had contact with, and they vaccinate all of them. Then they track down the contacts of those contacts and vaccinate them too.
You build a literal biological wall of immunity around the virus so it has nowhere left to jump.
Exactly.
And doing that in the Kivu region meant navigating an active, violent conflict zone, like negotiating with armed militias just to get coolers of vaccines to remote villages. It's an unbelievable logistical triumph.
Truly heroic work.
So, with treatments and vaccines, does the story end when a patient clears the virus from their blood and finally gets to go home?
Unfortunately, no. The aftermath is an area of intense ongoing study. Many survivors face a grueling reality known as post-Ebola syndrome.
Right.
The acute life-threatening infection is gone, but their bodies have been to war. They suffer from severe joint pain, chronic fatigue, hearing loss, and dangerous liver inflammation.
But the part of the research that I found most unsettling is the concept of immunologically privileged sites. The virus can actually hide out in the body, right?
Yes. There are specific areas of the human body where our immune system intentionally operates at a lower capacity.
Why would it do that?
It's an evolutionary choke designed to prevent aggressive immune inflammation from permanently damaging vital, delicate tissue. The eyes, the central nervous system, and the testes are prime examples.
Okay, that makes sense.
But because the immune system isn't constantly patrolling these specific areas with lethal force, the virus can seek refuge and persist there long after it has been completely wiped out from the bloodstream.
I read about this chilling case from 2014 in the sources. A patient survived, his blood tested completely clear, and he was officially discharged. But 2 months later, his vision starts failing rapidly.
Yes.
Doctors examine his eye and find the live virus swimming freely in his aqueous fluid. It's like a ghost lingering in the system.
It is deeply troubling. It causes severe ocular inflammation. We also know that the virus can persist in semen for highly extended periods.
Right.
National screening programs in West Africa recorded the virus persisting in survivors for over a year after their initial recovery.
A whole year.
Over a year. And while it's rare, this has led to documented cases of sexual transmission, sparking brand new chains of infection months after an outbreak was officially declared over.
Wow.
It means that supporting survivors isn't just about basic compassion. It is a critical, mandatory component of ongoing public health surveillance.
So what does this all mean? When we look back at the scope of this deep dive, this virus is truly a masterclass in biological efficiency. It's a tiny 80-nanometer thread carrying just 7 genes, yet it manages to exploit the very best parts of our humanity.
Our instinct to care.
Exactly. Our instinct to physically care for our sick and our deeply held traditions of washing and honoring our dead. It exploits our encroachment into the natural world. Yet, through rigorous, exhausting contact tracing, global cooperation, and cutting-edge synthetic antibodies and vaccines, humanity has managed to turn a once unstoppable ghost into a manageable, preventable disease.
It is a profound medical victory, without question, but it leaves us with a critical ongoing challenge to ponder.
What's that?
We discussed the environmental triggers earlier, deforestation and climate change.
Right, pushing the fruit bats out of the deep forests.
Exactly. We know that these environmental shifts are pushing animal reservoirs closer to human settlements. They're creating the perfect conditions for spillover events.
So it's not just random bad luck.
No. As we continue to clear the world's most remote forests for resources, and as severe droughts worsen, we are directly forcing these pathogens out of hiding.
It's almost like we're setting our own traps.
Precisely. We have these amazing medical miracles now, but we have to ask ourselves a difficult question. Are we just treating the symptom by creating these brilliant vaccines while actively ignoring the environmental disease that guarantees the next unknown virus is already on its way to meet us?
That is a staggering realization and a really heavy, necessary thought to leave on. We might have stripped away the loud cinematic Hollywood version of an outbreak today, but the quiet reality, the microscopic leaps from bat to human, the deforestation, the silent spread before the alarm sounds, that is a reality we all need to be paying very close attention to.
Thank you for joining us on this deep dive.
I want you to just, imagine a single family, and not just any influential family, but one that essentially invents modern banking, bankrolls the entirety of the Italian Renaissance, and somehow manages to produce, like, 4 popes and 2 queens of France.
Yeah, which is just an insane resume for one bloodline.
It really is. I mean, imagine a family that literally funds the invention of the piano, the creation of opera, and pays for the scientific discoveries that map the stars. And this is the crazy part, I want you to imagine that exact same family centuries later, just completely collapsing.
Oh, completely.
Like their final ruler is just lying in this bankrupt, feces-smelling bed, telling wildly inappropriate jokes while his entire empire basically crumbles into nothing around him.
It is a truly staggering arc. You go from shaping the very foundations of the modern world to just total grotesque decay. It's the ultimate rise and fall.
It really is. So today's deep dive is sourced from a really comprehensive historical overview of the House of Medici. And our mission for you today is pretty simple. We are going to kind of shortcut your way to understanding exactly how this family rose from these obscure agricultural roots to dominate Europe. We are extracting the absolute aha moments of their genius and, the bizarre, really messy details of their ultimate downfall.
Yeah, and to set the stage here, we really have to travel back to the 13th century. So to this agricultural Mugello region just north of Florence.
Right.
Because this is where the Medici story actually begins. And right from the start, there is this fascinating, almost deliberate ambiguity about who they even are. I mean, the name itself, Medici, literally means medical doctors in Italian.
Which brings us to one of the greatest historical debates in the sources. I love this part. It's about their famous coat of arms.
Oh, yeah.
It's this yellow shield with these very distinct red balls on it. And if you look at it and you know their name means doctors, you have to ask, are those red balls meant to represent medical pills? Or like maybe cupping glasses, which they used for bloodletting back then.
Right, or As some historians strongly argue, are they Byzantine coins?
Oh, interesting.
Yeah, because early on, the Medici belonged to the Money Changers Guild in Florence, and their official emblem was a red shield just strewn with coins.
But there's even a theory I read in the sources that they're just ripe blood oranges.
I've seen that one too.
Because those were grown in Italy and recognized for their health benefits long before anyone even knew what a vitamin was. It's just wild to me that a family this incredibly famous has an origin story and essentially a corporate logo that we still can't entirely decode.
It really is.
Okay, let's unpack this, because to understand how the Medici eventually bought the Renaissance, we first have to understand the actual mechanics of how they got their money.
That is the core of it right there.
Yeah.
And it definitely wasn't through royal blood. They weren't born into a monarchy. They didn't have divine right or anything like that. They essentially gained their massive wealth through revolutionary accounting.
Right, they were like the fintech pioneers of the 14th century.
Exactly.
In 1397, this guy named Giovanni di Bicci de' Medici founded the Medici Bank. But they didn't become the wealthiest family in Europe by conquering lands with giant armies. They did it with the general ledger system.
Yep.
They were among the very first to use double-entry bookkeeping. Now, I mean, I understand tracking money is important, but how exactly does an accounting trick build an entire empire?
Well, think about the physical reality of banking before this, right? If you are a merchant in the 14th century and you need to pay someone in another country, you physically had to load gold onto a cart,
Ugh, sounds awful.
put it on a dirt road, and just hope you didn't get robbed by bandits. It was incredibly risky and chaotic.
Yeah.
But what double-entry bookkeeping did was create trust without that physical movement.
Because it's a system of checks and balances, right? You record every transaction twice.
Right.
Once as a debit, once as a credit.
What's fascinating here is how something as dry as accounting fundamentally shifted the power dynamics of Europe. By having two columns that always had to balance perfectly, the Medici could catch errors and prevent embezzlement instantly.
Wow.
It allowed them to safely open remote branches. They can issue these things called letters of credit. So you could deposit gold in their Florence branch, get a piece of paper, travel to their London branch, and withdraw your funds.
That's genius.
Right. They were moving data, not gold. They knew exactly where their capital was across borders at any given moment.
I mean, if you've ever used a banking app to instantly transfer money overseas, think about doing that in the 1400s using just ink and paper.
It's mind-blowing.
It really is so similar to modern venture capital and big tech platforms today. The Medici Bank wasn't just a vault, it was a network.
Yes, absolutely.
They acted as the central hub connecting all the other elite families. Like, if you were a rival family, you probably had to marry into the Medici, partner with them, or work for them just to get access to the rest of the social and financial elite.
Exactly. And that network gave them unparalleled soft power. We throw that term around a lot today, but soft power basically means they couldn't just throw people in a dungeon like a king could.
Right, they didn't have a crown.
They had to manipulate the system to make people want to do what they asked. You have to remember, the Medici officially remained regular citizens of the Republic of Florence until well into the 16th century.
But they were totally manipulating the laws behind the scenes. The sources mention Giovanni backed a proportional tax system in Florence. Now, playing devil's advocate here, was he just a man of the people trying to do the right thing, or was this like a calculated weapon?
Oh, it was a highly calculated weapon, for sure.
Yeah.
Historically, the rich aristocratic families of Florence were, frankly, excellent at dodging taxes.
Shocker.
Yeah, placing the financial burden heavily on the poor and middle class. Giovanni championed a system that taxed citizens proportionally based on their actual wealth.
So he essentially weaponized tax law against his own rivals.
Precisely. It drained the wealth of the old money aristocrats while simultaneously making the Medici wildly popular with the common citizens. The people loved them because they perceived the Medici as their protectors.
Right. But having a monopoly on finance and being popular only gets you so far. Ledger money isn't physical power. To truly control Florence, they needed to control what the people actually did all day.
They needed a monopoly on industry.
Exactly. And in Florence, industry meant textiles.
Which brings us to a rock you've probably never thought about, but which fundamentally funded the Renaissance.
Alum. Yes. This was one of the absolute most surprising facts in the source material for me. A massive chunk of the Medici's 15th century wealth came from alum.
Yeah, it's a chemical mordant.
Right. And let me explain why this matters to you listening. If you dye a piece of wool, a beautiful, expensive, rich red, and you don't use alum to bind the color to the fabric, that beautiful dye washes right out the very first time it rains.
And Florence's entire economy was driven by the wool guild. I mean, they produced the finest textiles in Europe. For a long time, the Ottoman Turks controlled the only known major supplies of alum, meaning Christian Europe was totally dependent on them.
Right.
But then vast deposits of alum were discovered in a town called Tolfa, which was right inside the Papal States.
So Pope Pius II steps in and grants the Medici family an exclusive monopoly on mining that alum. Think about the tech analogy again. If the Medici Bank was the social network, this alum monopoly was like Amazon Web Services.
Oh, that's a great comparison.
It was the underlying infrastructure everyone else was forced to rent. If rival cities couldn't get alum, their textile industries literally washed away. The Medici could dictate foreign policy through chemical supply chains.
It gave them absolute economic leverage. I mean, they controlled the banks, and now they controlled the literal fabric of the economy.
But I was reading the source material on this, and I have to push back here. Wait, so they control the banks, and they control the textiles. Surely the old money families of Florence, the established aristocrats we talked about, who are already furious about the taxes, aren't just going to sit back and let these new money middle-class bankers completely take over their city.
You're absolutely right. They didn't sit back at all. Extreme wealth breeds extreme violent jealousy. The old aristocracy felt they were being choked out of their own republic.
Yeah.
And that brings us to the gruesome reality of 15th century pushback, the Pazzi conspiracy of 1478.
This part sounds like something out of a mafia movie, but it actually happened in a cathedral during a holy mass.
It did. The
Yeah.
Pazzi and the Salviati were rival banking families. They decided the only way to break the Medici monopoly was to, cut the head off the snake.
Right.
So they hatched a plot to assassinate the current head of the family, Lorenzo the Magnificent, and his younger brother, Giuliano. And they didn't just plan a quiet poisoning in a dark alley. They planned to do it during Easter church services, with the Archbishop of Pisa intimately involved.
The part that actually stopped me in my tracks was the Pope's involvement. The sources say Pope Sixtus V gave them a wink and a nod. I mean, how does a sitting pope justify a hit job in a cathedral?
Well, Pope Sixtus V had a fierce, long-standing political and financial rivalry with the Medici. The conspirators actually approached him for approval. Now, the Pope knew he couldn't put a signed assassination order on papal letterhead,
Obviously.
but he made it clear he would not interfere. More importantly, he promised them dispensation, meaning he agreed in advance to forgive any sins or crimes they might happen to commit in the service of the church. It was basically a blank check for murder.
Which is utterly terrifying.
Yeah.
So imagine this. It's Easter Sunday, 1478. The signal for the assassins to strike wasn't like a dropped handkerchief. It was the elevation of the host.
The holiest moment.
The holiest moment of the Catholic Mass, when everyone's heads are bowed. They draw their daggers. Giuliano is stabbed nearly 20 times and just bleeds to death right there on the cathedral floor.
Oh, it's brutal. But Lorenzo survives. He's badly injured, bleeding from the neck, but he fights his way into the sacristy and barricades the heavy bronze doors.
Wow.
Because the assassination attempt fails to wipe out both leaders, the Medici PR machine and their loyal citizens mobilize. The blowback is swift and brutal. The conspirators are caught by the public and hanged from the upper windows of the government palace.
It's just a shocking level of violence for a family of accountants.
But it perfectly illustrates the brutal reality of Renaissance politics. The Medici learned a very harsh, defining lesson that day. Your ledger books and your wealth cannot protect you if the people with divine authority, like the Pope, are willing to look the other way while you are murdered.
So, surviving an Easter mass assassination by rivals aligned with the Vatican taught them a clear lesson. If the church is your enemy, you can't just fight the church. You need to become the church.
Exactly. This is the massive pivot. We see the Medici transition from secular banking into divine authority. They systematically start buying the heavens.
Lorenzo the Magnificent realizes he can't just be a banker anymore. The physical security of his family depends on spiritual power. So he grooms his son, Giovanni, for the priesthood from a very early age.
Right.
He leverages all that vast wealth to push him up the ranks. And it pays off. Giovanni becomes Pope Leo X. And shortly after, Lorenzo's adopted nephew, Giulio, becomes Pope Clement VII.
If we connect this to the bigger picture, The Medici essentially captured the ultimate regulatory body of their era.
Yeah, that's exactly what it is.
No one could grant dispensations to murder them if they were the ones writing the dispensation.
It really is like a modern tech billionaire realizing that having all the money isn't enough, so they go out and buy up global media conglomerates and space programs.
Perfect analogy.
The Medici realized they needed to control the narrative, dictate the absolute laws, and secure their legacy on a permanent, untouchable level.
And their primary method of controlling that narrative was unprecedented cultural patronage. As popes and as the de facto rulers of Florence, they funnel their immense wealth into art, architecture, and science.
But I have to ask, wasn't that incredibly irresponsible? Like, they were brilliant bankers. Spending what is essentially their depositors' money and their tax revenue on ceiling paintings and statues seems like a terrible fiscal strategy.
On a pure ledger basis, yes, it was terrible. But the cultural ROI, the return on investment, was monumental PR. They weren't just buying pretty things, they were buying immortality.
Oh, wow.
They funded Brunelleschi to build the impossible dome of the Florence Cathedral. They patronized Donatello, Botticelli, Leonardo da Vinci, and Raphael. Pope Clement VII was the one who commissioned Michelangelo to paint the altar wall of the Sistine Chapel.
And they didn't stop at art. They literally bought into the cosmos. They provided safe haven and massive funding for Galileo Galilei. When Galileo discovered the 4 largest moons of Jupiter with his new telescope, he didn't name them after Roman gods. He named them the Medicean stars after the Medici children he was tutoring. Imagine looking up at the night sky and knowing a planet's moons are named after your family.
By associating their name with the greatest artistic and scientific achievements of humanity, they made themselves synonymous with civilization itself. You couldn't attack the Medici without attacking the cultural heart of Europe.
But there is a massive bill that comes due for all this, right?
Oh, a catastrophic bill. Pope Leo VI lived so lavishly and spent so heavily on art, endless banquets, and wars that he literally bankrupted the Vatican coffers.
Literally bankrupted them.
Literally. Empty coffers. They had to heavily push the sale of indulgences, basically selling get-out-of-purgatory free cards, which directly triggered Martin Luther and the Protestant Reformation.
That's a huge unintended consequence.
Right. Furthermore, Clement VII's reign was a geopolitical disaster that led directly to the infamous sack of Rome in 1527, where the city was utterly devastated, looted, and burned by the unpaid armies of the Holy Roman Emperor.
So they buy their way to the absolute top of the social and divine ladder, but the foundation of the house is crumbling under their feet. By the 16th century, they actually acquire formal hereditary titles. They are no longer just citizens.
Right, the mask comes on.
They become the Dukes of Florence and eventually the Grand Dukes of Tuscany. They even marry into the French royal family, producing 2 queens of France, Catherine and Marie de Medici.
They had successfully transitioned from savvy, street-smart merchants to untouchable, blue-blooded royals. But in doing so, they completely lost the very thing that built their empire in the first place: their hungry, innovative business acumen.
This brings us to the rot from within, because the juxtaposition in the sources between the early days and the 17th century is just mind-blowing.
Yeah.
On one hand, you have Grand Duke Ferdinando die in the late 1500s doing incredible things. He's draining marshlands to create arable land. He's planting mulberry trees along the roads to build a booming silk industry. He's even sponsoring exploratory expeditions to the New World.
Ferdinando was trying to act like a modern state builder. He was investing in infrastructure. But unfortunately, he was a massive exception to the rule of later Medici leaders.
Right, because if you fast forward just a few decades to the wars of Castro in the 1640s, the situation is incredibly bleak. The state treasury is completely empty. They have to drastically lower interest rates on government bonds just to survive.
It's bad.
The rural markets in Tuscany are so cash poor, they revert to a barter economy. I mean, how does a family that literally invented modern double-entry bookkeeping and international credit end up paying their army in barter?
It's the classic fatal trap of dynastic wealth. The founders are hungry, innovative risk-takers. They understand the value of a florin. But by the 4th or 5th generation, the heirs have only ever known the inside of a palace. They completely lost touch with the mercantile reality of the streets. They view the entire state of Tuscany not as a business to be managed, but as their personal piggy bank.
So they're spending money they don't have to maintain the illusion of power.
Exactly. The later Grand Dukes were obsessed with rigid religious protocol, bizarre alchemy experiments, and petty court dramas, while the actual economy withered. The sources note that by the late 17th century, the population of Florence had plummeted. The textile industry was dead, and grass was literally growing in the collapsing, unpaved streets of Pisa.
Which sets the stage for the 18th century fall. And honestly, for you listening, it is incredibly tough to read. The family is plagued by a complete lack of male heirs, continuous bankruptcies, and truly disastrous, incompetent leadership.
It culminates with Gaston, the absolute last Medici Grand Duke.
Jan Gaston is the polar opposite of his ancestor, Lorenzo the Magnificent. The sources describe him spending his final years entirely bedridden. He had this decrepit, bizarre entourage of young men called the Responti, who just drained his remaining funds. And his behavior was just grotesque. His sister-in-law would try to organize grand banquets to maintain some tiny shred of diplomatic dignity with foreign ambassadors. And Jean Gaston would be wheeled out, vomiting into his napkin, belching loudly, and telling deeply inappropriate, crude jokes to the guests.
He spent his final months in a bed that, as the sources explicitly note, frequently smelled of feces.
God.
He was physically, mentally, and morally decaying. It is a perfect, deeply tragic physical metaphor for the state of his empire.
It's a pathetic end. The family that built the Renaissance, that funded the Sistine Chapel, dying in a filthy bed.
Right.
When Jean Gaston died in 1737, the political and banking dynasty was officially dead.
Gone.
The great powers of Europe, Spain, France, Austria didn't even care. They were already carving up Tuscany, treating it like a piece of distressed real estate to be handed over to the foreign House of Lorraine.
But the Medici managed one final brilliant move, a move to ensure that while their political power was permanently gone, they would never, ever be forgotten.
And this brilliant move wasn't made by a pope or a grand duke or a banker. It was made by a woman, Anna Maria Luisa.
She was Jean Gaston's sister, and the absolute last biological member of the Grand Ducal line. She watched her brother drink himself to death in filth. She watched foreign armies march into her beloved Florence, and she knew the Medici name was about to be officially erased from the map of Europe.
So what does this all mean? What could one woman possibly do against the combined, heavily armed empires of Europe?
Well, she couldn't fight them with swords. So she used the one weapon the Medici had always understood better than anyone else in history, a legally binding contract. In 1737, Anna Maria Luisa signed the Patto di Famiglia, the family pact.
I want to talk about this because as I read the sources, I kept wondering why she did it. She willed all the personal property, all the grand estates, and crucially, all the priceless art of the House of Medici to the Tuscan state. She essentially handed it all over to the new rulers, the House of Lorraine.
But she included one ironclad, unbreakable legal condition.
Nothing could ever be removed from Florence. Not a single painting, not a single statue, not a single manuscript.
Exactly. The new rulers couldn't pack up the Botticellis and take them to Vienna or Paris or Madrid to decorate their own palaces. The art had to stay in Florence, expressly for the benefit of the public and to attract foreigners.
Now, was this out of a deep love for the citizens of Florence, or was this the ultimate spiteful chess move? Because by doing this, she essentially trapped the new foreign rulers.
Pretty much.
The House of Lorraine could never truly claim Florence as their own because they were forced to live forever inside a Medici museum.
It was almost certainly a bit of both. It was an act of profound civic love and a brilliant passive-aggressive trap. That single document is why Florence remains the cradle of the Renaissance today.
Right.
It's why millions of people still line up to see the Uffizi Gallery. She turned her entire city into an untouchable monument dedicated to her family's legacy. Even in her final years, she donated £4,000 a month to local charity and financed the completion of the Basilica of San Lorenzo, where her family was buried. She spent her last breath making sure the Medici PR machine would run long after she was gone.
It is the ultimate long game. The banking empire failed entirely, the political dynasty collapsed and ruined, the biological line went extinct. But culturally, the Medici achieved true immortality.
It's an incredible testament to the enduring power of art and legal foresight over raw political or military might.
It has been a wild ride for you today. We've gone from obscure agricultural merchants in the Magello region inventing the mechanics of modern accounting to surviving assassins wielding daggers during the holiest moment of Easter Mass.
Yeah, quite the journey.
We watched them manipulate tax codes, monopolize the chemical supply chain of Europe, buy the papacy, fund Michelangelo, and literally put their name on the moves of Jupiter. And we saw it all rot away into a bankrupt, bedridden, feces-stained end, only to be saved at the final desperate hour by his sister's brilliant ironclad contract.
This raises an important question, something for you to mull over long after we wrap up today's deep dive. Think back to the very beginning of our conversation, that mysterious coat of arms we couldn't figure out.
The red balls on the yellow shield.
Right. Were they medical pills reflecting their name? Were they the coins of the Money Changers Guild? Or were they just ripe blood oranges? Perhaps the historical ambiguity wasn't an accident. Perhaps the ambiguity is the entire point.
Because the Medici were the ultimate chameleons.
Are-
They were whatever they needed to be to survive and conquer in a brutal world. They were brilliant, calculating bankers when they needed money, populist politicians when they needed power, untouchable popes when they needed divine protection, and generous patrons of the arts when they needed a legacy. Next time you use a banking app on your phone to instantly send money, or listen to a piece of classical opera, or look up at a picture of Jupiter, ask yourself just how much of our modern world was essentially bought, paid for, and shaped by a single, ruthless, brilliantly ambiguous family from Florence.